Hi and welcome to another video from the Intelligent Auto channel. Some of you may have seen a short I put up last week about this MG ZS that I've got up on the ramp here with the high voltage battery fault. We removed the battery last week because of the fault, just to inspect it, and we found there was water ingress in the battery. The fault we had in the battery was P1B41, high voltage battery isolation fault. A bit nondescript. So download the technical information from the MG technical information site, and it basically gives us a description of the conditions for running the DTC. Basically it's an insulation fault, not an isolation fault. I think it's a bit of Chinglish going on there. Basically the car won't power up when the fault's active. If you can actually clear the fault, and the car will power up and drive, and then intermittently it'll put this fault on. The history of the fault is they've had the roadside assistance out to it a couple of times who have just cleared the fault and sent them on their way. It's also been back to an MG dealership, and they've basically drawn a blank. They didn't know what was wrong with it. So the fault occurred again, so they started doing a bit of research and they found us and called us and asked us if we could have a look at the car. So we got the car delivered on a recovery truck with the fault still active in the car because we wanted to know what the fault code was. And as I say, the fault was P1B41, high voltage battery insulation fault. The procedure for testing it is on here. Basically, it's saying that the insulation resistance is greater than 250 kilo ohms. There's a historic DTC which can be cleared, and the mill will go out after 40 wake over standby cycles, and it goes possible causes. Connector failure, combined charge unit failure, AC compressor failure, high voltage electric heater failure, high voltage battery pack electric heater failure, power electronic box failure, traction motor failure, high voltage distribution unit failure, high voltage battery pack failure. So it's a pretty nondescript. And it goes on about doing insulation tests on the car. We've already performed those insulation tests on the car, so the components on the car, like the aircon compressor and the drive motor, have all been tested and found that there was no insulation issues with them. So going forward, we advised the customer that we need to remove the battery pack because we can't do an insulation test from the connectors on the outside of the battery pack. There's switches, isolators inside the battery, which as soon as we unplug the high voltage battery pack, it will actually isolate the battery anyway. So we've got the battery out, we've got the lid off. I'm going to give you a walk around and show you what I found. So as you can see, we've got the lid off the battery. For those of you who haven't seen the previous little video, basically the cause of failure with this battery is, especially along this back edge, as you can see, there's water ingress through the seal. You can see the corrosion either side of this seal here. If you look down there, there's been a lot of water lying about. Inside this battery, when I first took the lid off, it was just dewdrops all over. There was so much condensation inside of it. So it's an insulation fault with the battery, but only an intermittent one. I think it's just been wherever the water's been lying. So yeah, one thing I'm going to make you aware of is, first time I've had an MG battery apart. I've had a few European batteries apart, Mercedes and BMW, and the first thing that strikes me here is, with the European batteries, see what the big orange bits are? That's the bits that bite you. With the European batteries, the insulation on these high voltage connectors is absolutely fantastic. You would have to be really, really, really stupid to be able to electrocute yourself by putting your fingers in, because there's no exposed terminals at all. But as you can see with these, obviously we've got the orange tags on them, but you can still see I could literally get my finger onto one of those if I had the desire to try and kill myself. There's actually a cap missing off that one there, which is interesting. Well, that's gone. But yeah, I could quite easily electrocute myself inside that battery. I've stripped down the last one. I think it was a BMW battery, and I didn't use high voltage gloves because I was that confident that there was no way of me electrocuting myself because the insulation on the high voltage circuit inside the battery was so good. This battery, I'm wearing gloves, and it's pretty dodgy. So yeah, so basically you can see there's more corrosion there, there's water being getting in there. See the water down there. So what we need to do is we need to take off all of these tags, all of these connectors between all of the packs, and we need to do an insulation test on each pack individually to ensure the insulation of the battery. The lid's been off the battery now for probably about 5 days, and it has dried out quite nice compared to where it was. There was actually puddles of water in there when I first took it out. I'll put a clip of the original video in. Take it to the back of the battery. Stick a light on. As you can see, I don't know if you can see better with or without the light, lots of moisture. There's water in the battery. If we go at the back here, put a light in there, we've got quite a bit. Basically furry aluminium. Look at those connectors. Soaked. All back of these packs are soaked, and this car actually drove in. Now what it looks like is this is the seal around the back of the battery. It looks like the seal's failed because we have lots of corrosion around that seal. There's a little bit of water ingress been coming through these vent holes here, so there's a bit of, you can see it's a bit cruddy there. You can sort of see where the water's been coming in, so this isn't a great idea, these vents. So I think we might need to have to take a look at them as well, and possibly either, this is the front face of the battery, so the car drives that way, so all of the shit and crap is going against this face of the battery, which when you think they put the vents on the back or on the side or something, or on the top even, out the way, but they haven't. So first of all, we're going to check the standing voltage of the battery. So I'm putting my gloves on. As I say, I'm not sticking my fingers in there. Not with the way that's constructed. I don't particularly like it. Nissan Leaf batteries are very similar in the way they're constructed. So I've got my multimeter. So we're looking for the final 2 connections coming out this pack going to this here, which is the high voltage breaker, which is coming from this terminal on this pack here and this terminal on this pack there. So we're going to go there and there, and we'll take a voltage reading 399 volts. So this is a 400 volt battery. So total battery voltage at the minute is 400 volts. We need to break that down. So we've got 1, 2, 3, 4, 5, 6, 12, 18 packs. I'm going to calculate on us. 400 divided by 18 is 22 volts. So we're expecting each pack to be 22 volts, which is safe. So if we can get the battery down to 22 volts per pack, I'm quite happy to stick my fingers in there without any gloves on. But at the minute I'm not. So another test I want to run before I start dismantling this battery is I want to check the overall insulation of the pack. So this is using this meter here. This is an insulation tester. So we're going to run it at 500 volts. So I've got the ground cable for the tester on the battery case in itself. We'll switch that on. And what we're going to test is from the final positive terminal of the pack to the battery casing, and from the final negative terminal of the pack to the battery casing. We're going to do an insulation test. So again, we're going onto that pack there, and we've got it set at 500 volts. So basically what we're looking for is what is the resistance. So we've got 16, 18, 20 mega ohms. So 30 seconds and we're at 30 mega ohms. So I'm quite happy the insulation's good on that side of the battery. And we'll do it from this one here. Run the same test. 30 mega ohms. 58's better. 65. Keep it on. So again, I'm happy that the insulation of the whole pack as it stands is good. So what we need to do is I don't think we're going to find an insulation fault with each individual pack, but it needs to be tested. So as I say, I'm going to have to start taking these caps off, which that one's missing, which is a worry. I mean, the only thing I've took off there is the battery management unit, which is under here. So unless it's stuck on the bottom of there, which it's not, I would say that it was possibly never fitted at the factory, because I really don't think this battery pack has been opened. So I'm going to work out how these caps come off, get some insulated tools and start stripping the battery. I'm going to work out first how to get these covers off. Up there. Hey. See me going from the side. Do them one at a time. Slacken them first. See, I just want to check there's no corrosion under each connector. From my work on high voltages, you don't want to drop anything in there. Just looking here, that's just a link wire between the two batteries. This is they must be CAN wires. Must have its own network inside the battery because there's only two wires there. They must be CAN wires. So basically CAN coming in, there'll be some kind of printed circuit board in there with the slave battery monitoring units on, and then it's one set of CANs is monitoring two packs, because every other pack has these CAN wires on. If you notice, I've got black tape around the socket here. I'm yet to come across a quarter drive. Ooh. Insulated socket set. This is 3/8. So what I've had to do is I've had to put a normal metal reducer on the end of it and tape it up with a quarter drive socket on. Drop there. Grab you. Oh, just fill in. Typical. And grab you. So I'm going to crack on and get all these connectors off. We'll come back to it when we're ready to get the packs out. All of the high voltage connectors removed from the battery pack. These two are just the ones going to the actual breaker. So we said we had 18 cells, 18 packs with a combined voltage of 400 volts, and we said each pack should be 22 volts. So let's test the theory. 22.2, 22.2, 22.2, 22.2. I'll do this side first. 22.2, 22.2, 22.2, 22.2, all good so far. 22.2, 22.2, 22.2, 22.2. Pop round the other side and do that last 8. 22.2, 22.2, 22.2, 22.2, 22.2, 22.2. So even though this battery has a fault, it has to be said, it is actually perfectly balanced. So there's no problem. It's not identifying one pack as being faulty. See, we've got perfect balance. So just as a belt and braces exercise, what we'll do is we'll do insulation tests on each pack. Grab the insulation tester, and what we're looking for is we're looking for any kind of short to the casing of the battery pack. So what I'm actually going to use, I'm going to use its own heatsink as the ground. So we'll switch that on. So we're going to go from each side of the battery and basically insulation to its casing. Click on that, press test. $500, $700, $900, $9,400, $1,000. This is mega ohms, by the way. 1,000 mega ohms. Test again. 7.5, 770. See, we're putting 565 volts. Oh, what's happened there? Oh, giga ohms. It's gone to giga ohms. Now that one's not so great. Still 35 mega ohms. 40. Just check I've got good connection. Try again. Considering this one was over 1,000 mega ohms, has that crud. Cause any issues? Try from that terminal there. $56, $60. I'll test this one again, just in case it was a bad test. Can't believe there's such a massive difference. 664. No, that's 3000. .2 gig. Open circuit. Oh, 16 gig. To more or less open circuit. Open circuit. Let's try these ones along the back here. Right. Around 45, around 55. Sounds like a 4 gig. Put the ground lead onto its own. So it would seem insulation's not the best on these ones that have had the puddle next to them. My 2 gig. My 5 gig. 219 meg, 40 meg, 47 meg. Still resistance there, but there's definitely 500. So is that proving something that this corrosion down here is actually causing an issue? And it would tell us to take the packs out. And have a look at the condition of the bottle under them. Based on the results of that test there, I haven't been right through the whole pack, but it would appear that the insulation on these 2 packs here is definitely still, it's not a short circuit. Still a massive amount of mega ohms, but why is it so different? I mean, these were giga ohm resistance. These are mega ohm. So I'm going to pull these 2 packs out and have a look. Those bolts feel clammy, they're damp. So I'm going to use my universal lifting devices to get these out, namely mole grips. Clamp them in there and onto there, and we'll lift that out. One. What this pink stuff is, you see the water. That's wet. What this pink stuff is, it smells like nugget. And 2. See the extent there now. So there's a heat exchanger under here, which basically is water pipes going on at the front of the battery pack here from the cooling system of the car. Run through plastic pipes here, then connect onto the base of the battery. So the base of the battery is basically filled with coolant, so it controls the temperature of the battery. We'll have to get them all out. As you can see, the compartments are divided. So these ones are dry, they're bone dry. This one's soaking wet, mainly in this corner. It's like, you know, I think this pink stuff's been oozing. Right, I think before I take any more, I'm going to number these so I know where they go. Right, so that's number 1, 2, 3, 4. Negative. It's the black one, positive. 5, 6. Just so we know. So there we have it. Dry that out. It does smell like nugget. Oddest smell. I think this white stuff here is potentially this. It's coming off this stuff here. I'm going to leave this to dry out. Mop up as much as we can. Scrape all this out. What the hell that is? My worry is it coolant. Has the heat exchanger failed? But it will be pink. Need to drop the car down and check the coolant level on it. I think I'm going to leave this to see if it will dry out naturally. Give it a day or so. It's quite warm at the minute. I don't think it is coolant. Let's say the state of this. I think that is a reaction between this pink stuff and water. To be fair, you can see where the water's getting under the seal there. Scruffy. Real bad design. Should bond them on really. They don't sell the internal parts of these batteries, so they're never intended to be taken apart. So you would think they would bond the lids, which they haven't. So you can see whether it's failed. So I think we'll sack this off altogether, clean this up, run a bead of CT1 around it, and then we'll drop the lid back on. That should be sealed up. So I'll leave this overnight, see how it dries out, see what it's like in the morning. So these batteries, the battery pack and the batteries have been sat exposed now to the atmosphere for a good 36 hours. Everything's dried up. I've mopped out the excess water out the bottom of the battery pack. I've scraped and getting the excess of the crud out the back and vacuumed it out. So I'm happy now. We're going to put the pack back together. Just one final test on these packs themselves, just to check the insulation on them. I've checked this technical data, and as long as the insulation is in the mega ohm range, it's acceptable. That's 1.2 gig. .4 gig. .5 gig. 11 gig. 88 meg. 17 gig. 67 meg. 90 meg. 200 meg. 2.8 meg. Increasing 4.6 meg. The last one, 330 meg. 335 meg. So they're all well within spec, so they can go back in the pack. That's number 6. So what's this end? Just locate them onto the dowels. Remember, we numbered them 1 to 6 from left to right. It's back in now. Right, time for the battery to go back in. High voltage connectors back on. That's it. And the low voltage. It's ground to put on. And the water pipes. Battery back in. What's left to do now? The 12 volt battery back on. The only spark we've had during this job is when I put the 12 volt battery back on. Set that on and see if it starts and moves. Right, here it goes. Press the start button. Ready? That's good. These mirrors folded out. And it moves. Can't move it off the ramp yet because I've got stuff behind it. So, happy days. Fixed. We've got another couple of jobs to do on this. We've got front springs to do on because I noticed one of the front springs is snapped. So we'll get them done and then we'll road test it. Make sure everything's okay. Well, the MG's been road tested now. It's fine. It's sitting on the ramp now waiting to get its front springs done. I noticed it had a broken spring when we had it on the ramp, and then it's going for an MOT. I hope you enjoyed this video as much as I did working on the car. I can't stress enough, if you're not qualified to work inside of a live battery, please refrain from doing it. This is not a how-to video, it's just to showcase what we do. If you enjoyed the video and you haven't already, subscribe to the channel, hit the bell for notifications, and I'll see you next time. Thanks for watching.